Maritime Made is sponsored by Invest Nova Scotia because great things are happening. Invest Nova Scotia connects your business with the right resources and opportunities. InvestNovaScotia.ca.
Aurea Technologies is a female-owned business based in Dartmouth, Nova Scotia. It's focused on making portable, renewable energy systems, and so far has developed a small wind turbine called the Shine Turbine that fits in a backpack.
We started in 2017 with a mission to decentralize and democratize wind power. We're female-founded, and we are manufacturing in-house here in Nova Scotia. This is technology that's useful in many different applications, and in a way, it's a bit of a deep tech solution that we developed. So we were able to identify a consumer application, and then also there are other markets that we can integrate into. So everything has been designed and thought of in terms of efficiency, lightweight, portability, and then also just being able to be cost effective enough for this market.
This product was originally designed by owners Kat Adelaide and Rachel Carr. Building one starts with many sub-assemblies. One of these is preparing the nose cone or lid of the device. Loctite is put on a socket, and this is slid into the nose cone. More is put in grooves for magnets, and it's set in a press. The magnets are placed in the upper half, and it's closed. It comes up attached and is pulled out whole. A motor is connected to a cowling, while screws are prepared with thread locker Loctite to prevent them from tampering. They're screwed in, and the mold is removed. And that completes the motor assembly. The nacelle is prepared with an LED light pipe and magnets using Loctite to seal all the way around these parts. It takes just minutes to lock them in place and 24 hours to cure. Lithium-ion batteries are tested to check that their voltage and internal resistance are spot on. After testing, a neoprene strip is placed between batteries facing opposite directions. And then, they're shrink-wrapped. Blade supports and blades are cleaned, and aircraft carrier glue is used to attach the supports onto the blades to make them sturdier. Once attached, these rest on a plank for 15 minutes to dry. Then they take another 48 hours to cure completely. Now that the sub-assemblies have been completed, the final assembly on this innovative product begins. To program the turbine's printed circuit boards or PCBs, the production lead grounds themselves. Then, boards are removed from their packaging. Each piece is cut out, and a serial number is added. One end is attached to the base of the other, and they're placed on a stand that keeps the boards from touching each other during assembly. The batteries are added and connected to a microcontroller and an external power source as it's in default mode. The microcontroller is used to program software onto the PCB board from a computer. Once the firmware program is successfully installed, the LED indicator flashes purple. The program is checked along with the battery. The firmware flashes red as it's hooked up to a power source. Each turbine has a quality control checklist that is filled out as it's assembled. The lower nacelle of the turbine is placed into the Loctite benchtop robot, and the PCB is placed inside. A pendant is used to program the machine and turn it on, so the electronics and productions technician can just press start. A needle adds Loctite glue to the parts. Once finished, the nacelle is lifted off and slid into a jig. Vaseline is applied to the connector cable, and this is attached to the USB port. The motor is attached, and its wires are connected to the PCB so it can be programmed. It's spun to see if it flashes red. Then the nacelle top is squeezed on with the USB and micro USB ports slid through the appropriate slots. These are screwed in and the nacelle is slid off. Tamper-free screws are dropped in and drilled. The finished unit is examined and tested before it's taken to the next station to dry for 24 hours. The 3 blades of the turbine are secured onto the rotor using custom-built hardware and Loctite. The nose was built to tighten the bolts on, both here and when the turbine is in use. It's used to attach the rotor and blades. Loctite is added to a tamper-proof screw and drilled to the rotor. A seal with more Loctite is added on top. In order for the nut-stop fasteners to fit, the blades have to be locked. Then, a nose cone is used to loosen them to open the blades. A spin test happens, and the blades are folded up before other quality control checks. When each turbine passes the final tests, its mounting system is packed into the internal cavity. This includes 3 tent pegs, 1 monopod collapsible mount, and a set of guy wires. A nose cone is clipped in, and a blade band is added, keeping it all together. Now it's taken to the shipping department, where it is visually inspected and cleaned. A custom Shine Turbine box is prepared, and crinkled paper for the bottom is produced. A warning label is added to the turbine, and it's packed up with a manual. The turbine is customer ready. Aurea Technologies Inc. will be releasing more renewable portable energy products soon.
We really think that microgrids need to be a big part of the climate change solution. And even though we're starting off with a really small wind turbine for charging USB devices, the technology that we've developed is essentially highly efficient wind turbine blades that are foldable, are portable. They're able to create high amounts of power in very turbulent and inconsistent wind conditions. And so everything about the turbine has been designed for durability, efficiency, usability. And so when we're looking to apply that to other markets and other verticals, we're going to be able to take that core technology and apply it to those markets as well.